Yes, Dr. Belina, madam.
Sir, Uday Kumar here, sir. Sir, Dilip sir is yet to join, sir. We're waiting for him.
Okay. Uday Kumar sir, venture for name join.
Okay, sir. Okay, sir. I just made him police. Sir, shall we start, sir?
Yes, it will go ahead.
Sonali, we'll just start a session, sir.
Yes, sir. Yes.
Uday Kumar, voice pendulum.
Yes, sir. Yes, sir. Audible, sir. Audible, sir.
Okay. Okay.
Sir, shall I start?
Yes,
Yes,
yes.
please go ahead.
A very good afternoon to all. Music is a moral law. It gives soul to the universe and wings to the mind. Let us start our event with Tamil Thai Valthu.
நீராறும் கடலுடுத்த நிலமடந்தை கெழிலொழுகும் சீராறும் மதனமென திகழ்வரத கண்டனிதில் எக்கணமும் அதில் சிறந்த திராவிடனல் திருநாடும் தக்க சிறு திரை நுதலும் தரித்தனரும் திலகமுமே திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம்பியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
We will have our traditional auspicious lamp lighting ceremony as a tribute to Mother Saraswati, goddess of knowledge. beautiful smile is the best universal welcome. It can make the day a good day easily. I invite Dr. Belina Vijay, Sara, Assistant Professor, Department of Computer Science and Application, BSc program, to give the welcome address.
Good afternoon to one and all. It's my immense pleasure to welcome each and every one for this 9 days national level workshop on DevOps. Even though the concept of DevOps was introduced in 2009, it took a long time to gain momentum and evolve. Our main aim of this workshop is to understand the key concept of DevOps and its tools like Git, Jenkins, Docker, Google Cloud, Ansible, Nagios, etc. I hope this entire workshop will help to upskill and upgrade the version of each and every one. Once again, I wish and welcome all the participants for 9 days workshop on DevOps. Thank you.
Thank you, ma'am. The way to get started is to quit talking and begin doing. Now it's time to kindle the event. I invite Dr. V. Saravanan, VP Academic and HOD, CS of SRM IST Ramapuram campus, to inaugurate the 9 days national level workshop on DevOps. I welcome you, sir.
Very good afternoon to all of you. Very good afternoon. So it's my pleasure and honor to be a part of this great national level program. I'm indeed happy to see the initiatives of the faculty members of computer science program and the MCA program. So it's the first of its kind. The programs are being organized in a joint way to share the expertise available in the programs or the departments. Of course, as mentioned by Dr. Belina, it is the need of the hour. We are talking about DevOps for the past so many years. But if you see the past, recently where the number of applications that it put it in the cloud, or the cloud management or cloud security, it has become so scalable, and the security issues are there. There are many things that we are talking in line with the cloud. So DevOps has taken in a multi-growth or multi-dimensional growth, I can say. There are many open source tools which has come up. I'm sure that this 9 days workshop will highlight the importance of DevOps and certain tools. We have chosen 7 best tools that is available in the open source platform. And as some of you know that we have hundreds of tools, or even more than 300 tools are available to implement the DevOps. So we have chosen 7 tools to give you some knowledge about what these tools are. If possible, maybe 1 or 2 demo with some sessions maybe from tomorrow onwards. So I'm sure that these sessions will give you some kind of directions of taking the DevOps, or taking the DevOps to the next level to the students, and which in turn can be useful for the intern. I declare the workshop open. I'm sure that the discussions and deliberations and what you are going to have will surely help you in some way or other. Once again, I welcome all of you on behalf of the SRM IST Ramapuram Faculty of Science and Humanities. I welcome you all for this faculty development. Thank you.
Thank you, sir. Now I welcome Dr. J. Dilipan, VP Admin and HOD of MCA, to deliver the felicitation address.
Thank you. A very warm good afternoon to one and all present here. It's a great pleasure for me to felicitate this gathering. First, I would like to take this opportunity to express my deep appreciation to the conveners and coordinators of this 9 days workshop from the Department of Computer Science and Application, BSc Computer Science and MCA program for organizing this wonderful event in a short of time. As you are aware that as the world of technology continues to evolve at a rapid pace, the demand for more efficient and effective software development and delivery processes has been exponentially growing. So this is where the DevOps comes into play. So it is the combination of development and operations, and also it has lot of practices and tools designed to increase the organizational ability to deliver the applications and services to the customers, and rather than the traditional software development process. So DevOps can be a good career opportunities at present for anyone who wants to work in the IT industry, and also it can be the highest paying job in the IT industry. So through the workshop, I hope all the participants can get new skills and knowledge, and also you will get a great exposure in this area. So once again, I congratulate and best wishes to the organizers and all the participants. Thank you.
Thank you, sir. In order to be unique, one must always be different. I invite Mrs. T. Kanimoli, Assistant Professor and Department of Computer Science and Application, to introduce the resource person. Welcome, ma'am.
A very good afternoon to all. It's my pleasure to introduce the resource person of today's workshop on web application development using DevOps. Dr. V. Saravanan is working as a Vice Principal Academic and Head in the Department of Computer Science and Applications, SRMIST, Ramapuram campus. He has completed his PhD in Computer Science from Bardiyar University. He completed his MTech in Computer Science and Engineering from Christ University. He completed his philosophy from Manonmaniam Sundarnar University. He completed his Master of Computer Applications from Bardiyar University. Sir is having 22 years of experience, which includes 15 years of post-PhD experience and 3 years of industry and R&D experience. He is an efficient researcher. He has published 80 plus research papers in international referred journals and attended conferences in Singapore, Sultanate of Oman, and Saudi Arabia. He has received 8 awards and achievements. He worked on various funded research projects. He is an editorial board member, reviewer in reputed journals. Sir has also developed various e-content modules. He has been invited as a resource person for various national seminars, workshops, and international conference. I welcome you, sir. Now I hand over the session to our resource person, Dr. V. Saravanan. Thank you, sir.
Thank you very much, madam, for your nice introduction. So, let us get inside the topic straight away. I will be dealing about the web development using DevOps, some bit about the introduction, and also I'll be talking something related to the tools that is available and what are the best tools that is available. Even though it is open source, we need to set some standards, right? We need to follow some standards. So there are plenty of tools available, as I mentioned. And what are the best tools that what we can think about using, the DevOps, or you can consider while using DevOps. And there is one tool, that I'm going to talk a little bit about its usages and implementations, and a bit about this architecture. Not going to be a complete, coding sort of discussion, some sort of thing. And so the objective of this discussion for the next something related to highlight some of the important aspects of the DevOps, why we go for DevOps, benefit the institution or the organization. And number 3 is about some considerations, some issues that we need to consider it. Somewhere or other, I'm sure that the last aspect will be of much useful for some the scholars or the faculty members, cloud-based applications, or even the cloud security and a few related things. So the agenda for this first session will be on something related to the introduction, and a bit about the life cycle, and we do follow some general, or traditional software engineering approaches like agile models and a few other models. In which way this development of the traditional models that we use, and some what are the principles behind using those DevOps, and some of the best tools available in the market for implementation or using the DevOps in a more effective way. So there is only one thing, in the introduction slide that I would like to emphasize. It's much about, we talk much about software engineering, we talk much about software testing, and that is what we teach as a faculty members to the students. So we have concentrated much on this, and we concentrated some of the validation or software maintenance, and going in depth in the software testing. Some of them maintenance, something. Only few of the institutions are concentrating on in the post-release of the software, that is IT operations. When I talk about IT operations, so once the software is rolled out, and as and when you get the new requirements, or as and when there is a changes, or some changes, needed in the existing code, right? And how we are going to act upon. We always talk about, server downtime previously. Right? The servers will be down for some time, maybe for some days or some important, operations. But nowadays we can see that, the servers we use, whether it's a Google or Facebook or Instagram, any server we use is always on, it is live. We never see that it is down for maintenance for 1 hour or 2 hours or even for 10, 20 minutes. If at all something is happening, it is a rare moment, maybe a few seconds or a few minutes, that's it. So what we are trying to talk here is about, so we would like to concentrate on both. That is, one side we talk about, developing and testing the products. And there is another case where the product is rolled out and it's being used by the end users, and there is a support engineer, sitting in the company or, somewhere to take care of this operations. So where the DevOps comes to the picture, where one side the developers, another side is operations. So that's what we can say, DevOps. So DEV means developers, right? And OPS means operations. So developers plus operations. These developers improve the testing also. So what the DevOps is, all the components together. Now the development, you will have the testing, and you will have the IT operation. The system will be on live, and when the system is running on live, you will be carrying out some maintenance activities without disturbing the normal execution. So we have to be more careful in this case. The reason behind the clubbing of this to have some sort of an integrity, or to have some sort of a communication between these two teams. Sometimes when the developer has done something and it is and it is not reaching the operations team, it may take some time. So the communication or the information flow, when you say, it takes maximum time, to reach from developer to operations, or sometimes operation people might be ready with the build, whereas it is not reaching, or developers, whatever it is. So we need to have some kind of excellent coordination, communication, and everything, within the two teams. So there is a reason why we go for a combination of developers plus operations. So by this way, deliver the operation, the requirements very fastly, and of course, whatever the requirement from the customer side, that can be done very easily. So what we are talking about here, what challenges we do have, and what solutions we have it here, right? So how does the DevOps addresses the developer challenges and the operation challenges, right? Both the sides, right? So let us talk about challenges that the developer has, right? When you talk about the first point, we see that the code deployment is very high. The time that you take to deploy the code is very high. You need to wait for such a long time, right? And sometimes we can see that the code management is also poor. It is not being maintained, managed properly, right? By way of not maintaining a proper documentation, or some organizations we can see that the change in the postman, right? It is done by somebody, and it has to be managed by somebody where the person has not managed the codes effectively. So, or the documentation was good. There were some changes, which is being requested, right? The voice is a bit clear now. Fine. So, documentation is, everything is good, right? So what we notice here is, the developers or the software engineers who is doing the job subsequently, they have not upgraded that. So, these are the two major challenges as far as the developers are concerned. So the code deployment time is higher and the code is not managed properly. Whereas, if you just see the DevOps, what solutions we have, right? So the deployment of code is weaker nowadays. There is no need of waiting for such a longer time, right? As I mentioned, there is no server downtime here, right? So, now the options, various options. Let us see how the things, or what various options are maybe in the thing. And the code management can be done more effectively. We have some tools that is available, open source tools. You manage the codes. You cannot just make some changes in the existing as it is. As and when there is a changes, as and when there are some deletions or new additions, code management is very important. So there are certain tools that is available in DevOps which will take care of the code management very effectively, right? And if you put the code in that environment, and whatever changes you do, it will be completely monitored. Right? This developer is concerned. Number two, if you see what are the challenges by operations, IT operations I'm talking about, right? So main thing is about the uptime maintenance is difficult, maintaining the uptime. So the server is down for some time and you would like to up it maybe within 30 minutes or 20 minutes. But sometimes we can see that, there are some builds which will take more than the predicted time, right? So automatically, the end users or the customers need to wait for such a long time for the maintenance, of course, right? Where we talk about using, the DevOps, the solution, right? So there is a maximum reliability of software uptime. We have some tools that is available as a part of the DevOps. Okay. And there are certain tools, even in the operation side, we use it for automation, particularly in the testing. But we can say that even the automation tools are not so effective. The reason behind the tools are not effective is, the incompatibility with the, the structure of the program that what we have, and and the structure keeps changing, or the modules keep changing, the classes keeps changing. So automatically, this, that what you use may not be effective. But whereas the DevOps, it's going to be an integrated thing, it's going to be highly effective, and the monitoring the server is very, very tough in the case of operations, right? You don't know what is happening in the hardware, right? I'm working in the software and I'm much into the software maintenance. I am much into the software build, upgradation, maintenance. Whereas the hardware side, I don't know. But whereas the DevOps has a tool which will take care of monitoring the hardware also, right? We talk about continuous monitoring here, right? So both the cases where we talk about server monitoring and feedback, when we talk about feedback, it's about the communication, the way that is given from the customer to the operations team, from the operations team, how it reaches the, the software development team or testing team, whatever it is. So, this we have an excellent system, an integrated system, which will take care of complete monitoring of the feedbacks. And the DevOps tools that is available make sure that the loop is closed. When I say loop is closed, the meaning is that the feedback given by the end user is being communicated to the maximum level, and the problem is solved, and see that it is being informed to the end users. So these are all the two main things, right? One side we are talking about the challenges from the developers and the solutions, and the challenges from the operations side and the solutions. We just put it in a nutshell in both the cases where we talk about the DevOps, right? So that is what we talk about. This is a relation between the development and the IT operations, right? See the left-hand side of this diagram, right? So we will write the code, we will build the models, we will test it, and we will release it. This is the job being carried out by the developer: coding, developing the build, testing, and releasing it. And if you see the other end, where we talk about deployment, right? Once it is the release is over, the deployment is done, right? And again, you need to go for operations. You need to keep on monitoring, plan it, and there are some plans in the form of feedback. Again, it has to be converted into code, right? And again to build, again test, etc. What we talk about here, in this life cycle, all the things are integrated. Whatever changes that you are making in one, say, the deployment, right? So it may affect the other part also automatically. We need to have, a proper communication, coordination, or we talk about uniform communication across all the parts. Here we have 4 parts on the left-hand side, 4 on the right-hand side, or 4 in the case of a developer, or 4 in the case of operations. So all this, things need to be, monitored and to be taken care very nicely. This is what the life cycle is all about. That is what we talk about here is, so the customers and they give their requirements, right? It goes to the developers. The developers take care of, developing and testing. And on the other side, we take care of operations. They will take care of, interacting with the IT infrastructure, whether it is compatible to the hardware or software. Sometimes software is working fine. There is no issue in the software. There is nothing, there is no scope for even further, upgradation. Everything is done as per the requirements, right? It works fine, but all of a sudden it goes off. The reason behind maybe in hardware. So, to tell that everything is correct and there is a problem there, or there is some problem in the storage or RAM or whatever it is. So automatically, what we talk about here is making use of the DevOps more effectively, right? Making use of the DevOps more effectively and see that everything is being used more effectively, and the communication is done in a very clear way. The traditional approaches that what we have, the agile approaches of software development or whatever it is, addresses the gap between the customers and the developer communities. Whereas there is no point we talked about, having developing a tool or common platform or or method to integrate all those things. Whereas in the case of DevOps, everything is available for you, and we can notice that everything is being done in a proper way, and we always notice that the requirements are properly given. Right? We understand that there is some break in the voice, maybe due to the rain or some reasons. So this is the main difference between DevOps and agile models. Agile is our traditional model that what we do. Right? What is the reason? Right. So we would like to focus first on the customer-centric actions. Or much of the models, we always talk about customer-centric models for relationship management. And whatever the feedback given by the customer need to be incorporated in a proper way by following the life cycle models or methods. So, the of the primary or first principle in the DevOps. That you will notice when you implement that. Okay. And the responsibility is from, and because I talked about feedback, I talked about communication, how it is being communicated from, say, one end to another end, right? Say from the customer to the developer, or from the developer to the tester, or from the testing team to the deployment team, from the deployment into the build team. Okay, that is what we talk about. So the responsibility is there, and whenever there is some changes, right, automatically the system will take care of that. Okay, and even when you are away for some work, right, we have some mobile apps nowadays, and whatever change you make, even you can just dictate it, and using the voice assistant, the tools that is available, DevOps that is available, will capture your requirements and will get the things automatically, right? And the architecture that is available, will take care of, establishing the communication in a proper way among all the users, right? Starting from the customer and the software developer and all the operations team. And we talk about continuous integration. That is what we talk about, continuous integration, right? And integration, we know it very well. We talked about this integration plenty of times in software engineering, right? And now we talk about continuous integration, right? Scalability. We talk about the customer-centric actions, right? Whatever was good yesterday, this not applicable today, right? In the sense, my requirement keeps changing every day or every hour. Sometimes you need to change it maybe at a very minimal time. So all these things are possible, by using this continuous integration. And we talk about automating everything. When I say everything, it's about your code, building the code and designing and testing and deployment and again customer requirements, planning, maintenance, everything. It's not just about developing a module and just installing it and coming out, right? And everything, whatever the customer is doing every day or every click, right? Everything is being monitored. That is what we talk about: monitor and test everything, whatever it is, right? So the customer navigation patterns are being identified nowadays, right? Or we talk about browsing patterns, like the same way the customer navigation patterns or click patterns, or what sort of things is being required by way of additional reports or whatever it is. So we talked about the collaboration for this reason. So they work together as a team. This is one principle behind this DevOps. Okay. And how we are going to do this? It's very important, right? We talk about automation, and we talk about monitoring everywhere, and we talk about continuous or possible using the automation tools. So we have some tools that is available, right? We call it as a DevOps automation tools that is available. Okay, so there are all these tools, information, all those tools are open source, right? So it is up to us to choose the correct tools, which is exactly matching your requirements, right? So based on the difficulties faced by the IT team as they manage their IT infrastructure, there are 6 classifications which is being given here, right? So the tools that is needed for to maintain your infrastructure, the tool that is needed for managing the configuration. When we talk about version control, right? Configuration management, deployment automation, right? Once the things are done, I want the build to be deployed automatically, right? So just think about a very complex or very critical application which is running. You don't want to down the server, but you want to just deploy it at no time. So how it is possible? Right? We have some automation tools that is available, and all those things has to be monitored properly, right? How the performance is during the peak time, or what is the peak time performance, what is the non-peak time performance, and how the build is, you know, you know, and particularly about user pattern navigation, all those things, and continuous monitoring. So all this 6 dimensions. We have some lot of tools. We have some tools, and we are going to talk about few tools which will really help us in building, or in automating these processes. Right? We talk about infrastructure automation. So the best example we can say is about the Google Cloud, right? So what we are trying to say here is so the best infrastructure automation tool that is available. Of course, we have the Microsoft Azure, we have the AWS. That's fine, right? So there are some things that is available here when we talk about Google Cloud. It's about scaling on demand, right? So that is you don't need to be physically present to manage your data center, right? Automatically the system will take care of everything, right? So if at all your action is needed, it will just send you a message. That's all. You don't need to keep on monitoring your server, particularly when the concept of infrastructure comes. So we don't talk much about the hardware here because all these things are shared in the cloud. The upfront hardware cost, because it is you know that the cloud cost is very cheap nowadays, right? And it is easy to configure AWS also based on the requirement, whatever it is. We can integrate some of the things that what you practice in Google Cloud and can be integrated with other platforms also. And we have a tool called Chef that uses configuration management. So Chef is one of the tools. It is used by the DevOps people. Just test the speed, agility, the scaling, and how consistent it is, right? And there will be some complex or more critical jobs in your module, right? So the system will take care of everything. That what we are trying to talk here, right? So you can make the changes in one place. Automatically, it reflects in all the servers. You might have installed your apps in, or 10 or 15 customers, right? That is, you might have delivered your bill to 10 or 15 customers, right? But once you make some changes in your machine, automatically by using the concept of virtualization, it takes care of automatically updating it, in all the cases. So we talk about automatically reflecting to the servers. And the third such tool that is available, particularly we use it in the case of deployments, right? So we talked about continuous integration, continuous testing, right? So we're not talking about the tool used for testing here, right? There's a tool that is used, to monitor the testing process. We can think about using a separate tool for testing like Selenium or any Windrunner, Roadrunner. There are many testing tools available. Monitor that. So what I'm talking about here is the Jenkins tool, or the previous day I was talking about the tool called all these tools will sit above as the monitor and will just keep on monitoring all the existing other such tools that is available. It will sit above that, it will act as a supersection, right? So all those changes that whatever you are making can be made more effectively using the Jenkins. Again, it is an open source tool. Particularly this, we use it only for automation. Of course, Chef will work only for the configuration, whereas Jenkins will work for the deployment. So what I was talking here is about the 6 parts, critical cases, categories we talked about. right? So based on they given by the IT team as they are managing cost itself. So this 6 categories, what are the tools that is available? So we talked about Google for infrastructure automation. We talked about a tool called Chef tool for configuration management, and we talked about the Jenkins tools for deployment automation. There is a tool called Splunk. Again, it's an open source tool. We use it for the log management, right? All the things, whatever you do, day out like that, So when a code comes in or the requirement comes in, when the requirements are converted to code and code is converted or design to code to testing to deployment. So all the things are being captured or navigated, these navigations are very nicely using this tool. And not only just capturing the data, but also we'll do some kind of analysis. Like we can take some action based on that. We talked about sorting, we talked about something called aggregation. So something like management tool that is available to monitor the logs, to monitor the activities, and the outcome. Whatever data that you get it, you just do some analysis, and the analysis will give you some outcome, and that outcome is again used by the system. There is a beauty of it. We talk about app dynamic. We use it mainly for performance management. This is very important, right? So because it is continuous monitoring, we talk about real-time data. So continuous monitoring is very important. But the tool that is available, as a part of your existing frameworks, are not that to this, the expectations, right? And whatever tool that we talk about, when I talk about performance management, whenever there is some problem happens, whenever there is a bug, you do the debugging and fix the errors, right? So, and this tool will take care of all the data, which will help the developer in debugging the code and fixing the errors, right? So it's sort of something like a helping tool for the developers based on our previous experience. And we do have a tool called NagUs, right, or NagUs. So again, we use it for continuous monitoring, right? So it makes sure that the server goes down or there is any technical issue, automatically it takes care of informing all the people and this and all the other software modules associated with that, right? So this is one of the tools that is being used by most of the DevOps developers. The DevOps, there is one team developers, there is one team of operations. So DevOps and developers to find and fix the issues, right? So as they do that, right? Categories. What are the top trending tools that is available as on today? Right? We talk about one tool called Kubernetes. Again, this Kubernetes is developed by Google, and they're using Google is using this and as you know that it is an open source tool, right? So now for particularly for the DevOps processes, so there is something called containers. We'll talk back to the next presentation, right? So the Kubernetes is one of the tools that we use it, particularly for container-based applications. We talk about deployment automation, we talked about container scalability and maintenance of all those things. So this Kubernetes tool will take care of all those things very excellently. We'll talk just a bit about Kubernetes after we finish this another 4 or 5 slides. There's another tool available called Docker. Of course, maybe tomorrow or day after tomorrow, other speaker will talk about this Docker. It is an extension or another version of this container we talked about, right? So this is Docker. Will have it's like a package. You'll have all your library files, or binary files, and the configuration files. The things, whatever we do in the container, we can do in Docker also, except that where we concentrate much on the binaries. It is one tool that is available. We'll be talking about binary maybe tomorrow. And we have another tool called JIT. It is again a version control system that we use it, right? All the things. It just monitors your complete life cycle period and all the things, we talk about distributed development, right? And all the JIT will take care of the versioning control in a more serious way. And we have some tool called Jenkins. It is again a top tool, right? We use those tools for integration, right? So written by developers, particularly for the developers who return the code using Java. You know that again, Java, because of its nature and a lot of other features, it's being used exclusively in few applications. So wherever Java is used, mainly use it for the integration server during the testing the code and reporting the changes in the real time. Like, and it has a lot of plugins, more than 1,000 plugins, right? And the other beauty of this Jenkins is the scripting, so automatically it takes care of there's something called pipeline scripting one by one. So as and when the need arises, as and when you get some new request, automatically the Jenkins will take care of generating the scriptings very nicely. There is something called Ansible, right? So it is again for automating the application, right? So there are a lot of things that we do, particularly for the deployment phases. We talk about network configuration, and we talk about some kind of a configuration tools that is available. One side we talk about push, and whenever there is a push, there will be a pull. Whenever there is something that you are you are adding something, sometimes you may remove it also. So whatever it is, this is again an excellent tool that is available to automate the application, Ansible. And share my other screen. There's something called, one tool, we'll talk about this for quite some time, maybe for another 6 to 7 minutes, is about Kubernetes, So what made us to have this initially? Even though we have some other tools that is available for coding and all those things. So let us talk, a bit about this Kubernetes platform. Well, let us talk something about this containerized applications. Before getting inside this Kubernetes, it is one of the prerequisites. Every one of us, we should know what is this, container-based applications, right, or containerized applications. We all might have taught to the students about the concept of encapsulation, right? Or we talked about something called data binding, right? Or you might have taught something related to packages, which is available in Java. So a lot of things we taught related to the concept of encapsulation, right? So the container is simply nothing but an application that run in an isolated environment called container. And we have something called container. It is a software unit. We have all the dependencies. You just say a container. The container will have all the dependencies such as libraries or binaries and configuration files, whatever is needed to run that particular software. The container will have. It is simply nothing but an all-in-one packaging. That's all, right? And I'm sure that every one of you have some knowledge about virtual machines, right? Or running virtual operating systems, or whatever it is, right? So it will have. It is developed. The container is developed, or container has a Java executable code and all the system libraries. And now you have this container, and this container can be hosted anywhere. It can be hosted in a Windows operating system or a Linux platform, iOS platform, anywhere. So you don't include your own operating systems, right? So the containers, you are using the operating system to develop the code, to develop the container, that's it. Once you develop this as a container, it is independence. It is independent of the operating system, right? We talk about virtualization here, right? This is one thing that what I want you to know about this containers. So what this Kubernetes, of course, it is an again free and open source technology given by the Google. Right? Particularly this, we will use it in the deployment phases. Right? What is the reason why we talk about the deployment before the coding, before the building, is about how is understanding about where you are going to deploy, where you want to use these tools for your future. There is a reason, right? So this Kubernetes, the technology is being used by giants like Google, Microsoft, IBM, and even Alibaba to run their container-based workloads, right? Irrespective of the operating system they use or whatever it is, right? So what makes them more different from that of the other people, right? So as the diagram sees, it's a container. You know what a container is. So the container contains all the related things within. It was first released in Google, and nowadays it is being used by the developers, to set up an automation of the deployment tools, right? And being an open source, it has become so popular nowadays. We talked about an effective tool, that is a technology that is available. Right, Kubernetes is again an open source and a free technology that is available for us to implement our container related applications, right, by including all the necessary libraries and the other services that has, right? And what this container is and why it is used in Kubernetes. Of course, and technically, if you want me to say, I can say that container is nothing but a virtual machine running on a single physical server. That's it. It's like it's a virtual. You feel like it is available everywhere, but it is not. So it is just a mission, one mission. You would feel like everything is in your system, but once you close, once you stop the services, no, that is it is not visible to you. You cannot make any changes, right? You cannot do anything, right? It's just a virtual mission. Right. So that has been configured to give you some kind of services, right? And it has all the things that is needed in whatever it is, the OS libraries or the deployment libraries or binary files or the configuration files, right? So what is important here is any application, you need to install the dependencies in the container. You make sure that the container has everything. Right, and this Kubernetes technology, by using the concept of containers, it's being so effectively managed during the deployment stages, particularly during the deployment stages. Right? What is the reason? One thing is about the automation features that we have in the case. So we talked much about the automation features. There are plenty of cases, maybe in the previous slide. Even we talked about automation. So the Kubernetes supports for automation in many cases. About the scalability, right, is very important nowadays, right? Scale up or scale down, right? So where you are, irrespective of what applications you run, irrespective of the number of users, whatever it is. And one side is about the cost savings. So there is no need of spending much money or even money at all to buy any technology. The technology is it's a free and open. And you can even think about downloading it and customize it for your need. There is nothing called licensing fees. And at the same time, since it is open source and free, don't worry much about the security. The security features is being much implemented here, and the famous we are companies like the Google or Netflix or Amazon, they use the stability, the Kubernetes platform more extensively, particularly for the deployment of their containers in the clouds, right? And we have some best open source monitoring tools for Kubernetes. What are the tools that is available to implement this Kubernetes technology? We have something called FPO-org, and FPO-org is again a tool that is available for you to have the containers in a more secure way, and even during the deployment cases, whenever there is an issues in the container, within the container, right? When there are some issues in the library and other things, so the FPO-org tool will take off, troubleshooting that issues automatically. There is something called New Relic tool, right? So this again for the monitoring here during the deployment stages. It is for monitoring issues related to the performance, and will provide you the alert wherever is needed. So for Prometheus, again it is an open source tool, right? So it is like for the previous tool. This also we use it for the monitoring tool that is available. We have something called CloudWatch, right? It's from Amazon. We have something called Grafana tool, right? And this again for monitoring and reporting during the deployment stages. And Alert Manager is again we use it for applications which is in line with the healthcare or quite critical manager. So overall, this cluster will be like this. So underlying architecture, underlying infrastructure, if you see, right, we have the physical machine, which will have a virtual, machine which is running, and we use the cloud. It may be a private cloud or public cloud or hybrid cloud, whatever it is. Okay, and we have the control plane in this Kubernetes cluster, and you know that everything we operate using the container. So we have a persistent storage and we have a container registry. The container registry will maintain all the details about the containers, right? We have the containers, and we have the kubelets and kubeproxy, right? These are all the virtual machine, or the methods that is available to monitor the containers more effectively. On the other side, we have the Kube API server, and Kube scheduler, and Kube controller manager, so which will take care of completing the communication of all the containers. So overall, it is simply nothing but architecture. I can say it runs on a virtual machine, and see that you get a clear idea about what this Kubernetes is all about, and what are all the various other open source tools that is available to support the Kubernetes. So the conclusion here is it is a free and open source project. It's being extensively used by many cloud providers to run their container-based workloads. So how to develop a container, how to run it, how to use this kind of platforms, it will be discussed maybe in the days to come. So we will be talking something related to Dockers in the future. So where we will develop the containers, and all the containers, using the Docker application. So today's session, we have given you an overview about what this DevOps is and where do we use this DevOps. And one such tool, technology that is available is a Kubernetes technology. So we talked a bit about the technology today. Maybe in the sessions to come, you will get a clear idea about the technology alone, right? Possibly with a hands-on, a session or a live demo or a case discussion of all these things. So with this, let us wind up the today's session. If there are things, I am ready to take it up.
Sir,
Yes, ma'am.
dear participants, now the feedback link will be posted in the chat box. Kindly fill the feedback. There is no separate link for attendance. It will be considered as the attendance. All the participants are requested to fill the feedback form. It will be posted in the chat box. Thank you.
Participants, if you have any queries regarding, you just unmute yourself and you can tell your comments. We have given unmute access right now. If you have any queries regarding today's session, you can unmute yourself and you can ask the resource person. Otherwise, if you can't able to unmute, you can post the content in chat box.
Feedback link. There's more?
Okay, sir. Okay, sir. I will post, sir. 1 minute, sir.
About Nginx. Nginx is a tool we use it for application delivery. Okay. So particularly during the application delivery, we use it to monitor the performance and record the log related activities of the application that you want to deploy. Not ready? They can fill up the feedback and leave it, right?
Yes, sir. Yes, sir. Participants, you can fill the feedback form. The feedback link is available in the chat box. Just once you fill the feedback form, you can leave the chat. And the tomorrow session will be at 2 to 3 o'clock. The meeting information will be shared through the WhatsApp group. Okay. If you have any doubts regarding, you can ask. Otherwise, you can end up the call. So I think one person from the chat box, Ilakia, is asking what is the full form for DevOps, sir?
Yes, so given it, developer plus operations.
Okay, sir.
Okay.
That's it, sir. I think there is no
Okay.
queries from the participants. Thank you, sir.
Thank you.
Thank you, sir.